Hello everyone, and today we'll be seeing one of the problem from GeeksforGeeks. It says meeting rooms. The problem is very simple, that we are provided with a 2D array where ARR of I of 0 is the starting time and of 1 is the ending time for ith meeting. The task is to check if it is possible for a person to attend all the meetings such that he can attend only one meeting at a particular time. A person can attend a meeting if it is straight time, is if it is starting time is greater than or equal to previous meeting's end time. So such is the example, and as you can see that 1 to 4 doesn't clashes, and he can just go ahead and then enter 7 to 10 and from there 10 to 15. So yes, it is true, he can attain all the three, but in this case he cannot. The reason being very simple: 2 to 4, next he goes for 6 to 10, but if he attends 6 to 10, 9 to 12 is not possible. So with this thing in our mind, one thing is pretty much clear, that we need to attend all the meetings. Then in that case, I'll just write it down: attain all meet. So how can we understand, can this array A be possible to attain all the meets? One thing is, you take a meet I and check with the rest of meet J, all the rest I'll say, and then you can easily count that hey, if a meeting intersects, then he cannot attain. So overlap, then strict no. But can we do it better? Because this algorithm here would consume a time complexity of O of n square, and we don't want that. Can we achieve a better one? So coming back to our example, we from here deduce that hey, the person can first attend meeting from which will end at 4, then from 4 he can go ahead and attain the meeting starting from 7 to 10, and he can then go to 10 to 15 and 1 to 4. Yeah, this is, you can see that hey, these meetings are arranged in terms of order. So either you start with start first or end first, doesn't really matter much because this is a very simple problem. I'll go ahead with end first for random reasons, I don't know, because I just wanted to go. So end first, I will sort it. Once I'm sorted it out, I am clear that hey, what all next persons which are coming behind me, these are sorted, because once I'm ended here, I can then go to the next. So arrays.sort this array A, where if I'm having two index, which is II and JJ, I wanted A of II of 1 minus A of JJ of 1. So this is sorted ascendingly in with respect to the end first times, ending times, and I would have a variable which is last. This would denote what is the last meeting I have attended. Initially I am attending 0th meet, and if I am attending 0th meet, rest all meets are from 1. That is obvious, right? So I'm from 1, I'm attending the rest all till the length meetings. I'll just check that hey, if my last meeting's end time, if it was greater than this meeting's start time, this meeting is A of I and its start, then obviously I cannot, so this overlaps. Why? Because the last hasn't even ended yet, and how can I attend the upcoming meeting? So this is an overlap, and hence I'm returning false. Obviously if this doesn't happen, then the last meeting I have attended is A of I, so I'll update last is equal to A of I, and ultimately I'll return true, because There is no case of overlaps and hence the answer is true. Let me try to compile this one for any compiler errors. Okay, there are few. What does it say? Okay, my bad. I should be here, and this should be 1, and this should be 1 here. So this denotes an element of A. How should I treat this? So treat ending index only. So that's what it means. So let's try to compile this one. Okay, it has compiled successfully. Let me try to submit this in. Well, it has been submitted for rest of all the test cases, and yeah, this was a problem which we have solved in n log n time complexity because the sorting was the operation which we took. It took time there. Else, rest of thing is in O of n time complexity. This can be categorized under greedy and sorting. So this was one of the problem, and for more such greedy algorithms or data structures or in general videos, click the video on your right, and I'll see you in the next one.